Okay. So a couple quick announcements. This doesn't pertain to y'all so much because my office hours are already have already happened. But if you came to office hours today, I wasn't there. So hopefully you saw my email. This is very unusual for me to cancel office hours 2 times in a row, I assure you. I know y'all don't know that because you've never had me as a professor before, but hopefully this will be the last time this summer I need to cancel office hours. But because of that, your take-home quiz 4 got extended. It was due today, but I extended it to Wednesday, just to give you a little bit more time to get help from tutors or from me in office hours on Wednesday. So that was a nice perk of having my office hours canceled today. Also, your test 1 grades have been posted in the Blackboard gradebook. So if you haven't checked that out, go ahead and give that a click. We'll talk about test 1 in just a sec. And the last announcement is that I posted some new videos in Blackboard under homework help. So remember, that's a resource. As I get email questions from students, if I make a video, I'll post it there. I had some old videos from the last time I taught this virtually, so I just added them to the link. I also emailed out a hint to question number 3 on Take Home Quiz 4, and I added that in the homework help link. So that's it. There was another announcement that I didn't put on here. Let me think. What was it? Oh, yes, on the 3.6 notes. So the notes we were doing on Wednesday, the 3.6 notes, question number 3. Remember that one? We got it started, and then I made a separate video. I just wanted to let everyone know that the calculus part of that could very well be on a test, a quiz or test, right? So remember, there was a function. It looked something like this. I'm not remembering exactly, but I'm just making something up. I think the function looked like this or something. So you will need to know like how to take the derivative of both sides of this, where x was a function and y was a function. Like that part, the calculus part, you'll need to know, but all the algebra, having to use quadratic formula to find a missing variable, to plug back in, all of that, I will not test you on that. It's still important algebra skills, so still watch that video I posted. You'll need to know that algebra, but I won't put a question like number 3 from the notes, this 3.6 notes on test 2. Okay, so now that I've gone through those announcements, are there any questions or comments before we talk about test 1? Okay, well then let's talk about test 1, y'all. I wish I could share my camera because it feels so weird talking to a screen, a blank screen, but my connectivity is too low today. But okay, so the test 1 results were about par for the course. The average is about the average on test 1. Test 1 is usually the lowest averaging test of all of the tests in this course, so I wasn't shocked by the test grades at all. Some of y'all did awesome. Some of y'all not so much. So when you clicked on your test grade, if you saw your grade and you were like, yes, that's awesome, high five, keep doing what you're doing. If you saw your test grade and you were bummed, okay, the average in your class, I believe, what before the curve was a 65. I don't know. I have to look up the column. Which the average in this on this test is usually a D, a 60 to 65. Somewhere I've taught this course. This is my 12th year now teaching it. Test 1 is rough for a lot of students for a lot of different reasons. So it was about normal. I did choose, even though the test results were normal, even though it's what always happens when I teach this course every time, I did choose to curve the test grades 5 points. I've never done that before, y'all. This is my first time in 12 years of teaching this course. But the reason why I did that was because of the virtual environment. I know we've had a lot of technology issues this summer that made us rush a little more than I have in the past. So I just decided I'm going to give everyone 5 grace points, no matter what your score was. So some of y'all ended up with 105, and some of y'all, 5 points just got added to everyone's test, whether the technology issues affected you or not. So, but just a couple things before I open up the floor, just to questions and comments about the test. I noticed 2 main things when I was grading the tests. First of all, the scores were very bimodal. So that average of 65 that I mentioned, I'm pretty sure your class was the 65, that's about normal, but the scores were very bimodal. What I mean by that is the average doesn't really tell me much, because students either got an A or a B or a low F. It was like either knew it or you didn't. There weren't very many C's mixed in the middle. It was like lots of A's and B's, lots of D's and F's, and they kind of average out to the middle. So that average of 65 is very misleading. There were lots of A's and B's in this class. I can pull up the stats later, but half the class did really, really, really well, and the other half the class did not. So if you were in the half of that class that did not do well, there's still hope. Don't feel like there's no hope. You just have to be honest with yourself and ask yourself why that happened. Okay, was it the online format? Was it the accelerated pace of a summer course? Was it a lack of algebra confidence? Was it outside factors that had nothing to do with school that was preventing you from studying and putting in time and energy? You really need to nail down what happened on test 1 so you can make adjustments between now and test 2. And like I said, if you were happy with your grade, high five, just keep on doing what you're doing. If you weren't, come see me. We can talk through a strategy to, work towards test 2 and have different results on test 2 there. And I will say, let me just share a whiteboard real quick. So say, for example, you made, here's test 1. Let's say you made a 50, okay? If your goal is just to pass this course, it's totally doable, because we still have test 2 and test 3, and you still have your, My Math Lab homework and your take-home quizzes, like, still at play, right? So if you got 85 averages on the My Math Lab homework and the take-home quizzes, and you make probably, let me crunch the numbers real quick, but I'm guessing maybe 75s on the next 2 tests. Yeah, probably 75 on test 2 and test 3. That could still average out to a C in the course. So there's still hope, but you just need to change the way you prepare for your test, right? Something has to change between test 1 and test 2 to have such a big jump in your score. Now, if you are below a 50, you'll have to get much higher scores on those next tests, right? And much higher homework averages. It's all a game. So if you want to come to office hours, we can crunch the numbers. We can see what your goals need to be for test 2 and test 3 moving forward. And yeah, I'm here to help talk you through that. So I don't know, I'm just going to open up the floor. Any questions or comments about the test? Yes, hi. You'll see 2 columns in the grade book. So there's a column that says test 1 submission. That's what you submitted to me, and that's going to have your feedback and your raw score. And then you're going to see a column that says test 1 grade. I kept it separately just for my knowledge, and that has the 5 points added. So this is what's going into that overall average calculation. But your feedback is actually on your submission. The 3 points for the camera check, you'll see that on your feedback. So let's say you got a 78 as your raw score, and then if you see a +3 written on the submission, that's showing your camera check. But I added the 5 points separately because everyone got the 5 points. Not everyone did the camera check. So I kept those separate just for my knowledge to help me when I'm looking and helping crunch numbers for students. So Alex, that's hard for me to answer. Alex is asking, did anyone else not finish? I know I had some students choose to leave questions blank. When I was checking their submission, I asked, did you intentionally do that? And they said yes. I will say that this test that y'all took, when I give it in a face-to-face class, I've given similar versions. They only have an hour 20 minutes to take it. Y'all had the hour 40 because of the technology issues. Yeah, no, I totally get it. It's a very valid question. The online format always adds more time, especially if you aren't able to print your tests. I know that's one of the big downfalls of this online testing. If you don't have a printer, it can be a disadvantage. For sure. I will say question 17, there wasn't really a most missed question. I have a spreadsheet. I could pull it up without the names later. So what I do is for every student, I have every part of every question and the points missed, and I do this big analysis. Oh, Rosa, can you email me and I'll just double check? And Mariah too, email me and I'll double check. There should be a column that says whether you got those 3 points or not. And yeah, just email me because I'll forget. But if there was a most missed question in this class, it was question number 17 about where you had to construct the revenue function. And then, so construct a revenue function and then find the marginal revenue. So find R prime of X. That was probably the most missed question, if there could be a most missed question in this class, because over half the students got it right or almost completely right. And the other half of the class missed at least one part. But I went back and just to double check, and it was in the notes and it was on 2 homework questions. So I feel like it was represented in class. But the way I grade, just so you know, part A was asking you to construct the revenue function, right? So let's say you got part A completely wrong. You just totally missed the mark. You missed your points for that. So you would miss those points. But then what I did was whatever your wrong answer was, I took your wrong answer and I reworked problem B. And if I got the same thing you got those points. And then I took that wrong answer and I reworked part C. And if we got the same thing, I gave you those points. And I did that for any multi-part problem. That's why it took me so long to grade. So it wasn't an all or nothing scenario. If you got one part wrong, I used your wrong information to rework the rest of the problem. And if you got that concept correct, I gave you the points. So Alisar has a good point there. Doing the word problems first, like when you have all that fresh energy, made her feel like that she had more time when she got to the easier problems that were more computational. Yeah, 11 or 12. And Alex, come see me in office hours and we can look through your test on 11. I don't remember what 11 and 13 was off the top of my head. Y'all did awesome on the limit stuff, though. I'll give you a high five on that. That's usually what, oh no, the notes are in the trash folder. I thought I relinked the calendar. Let me check that real quick. Wait, they're weird. It's pulling up for me. Let me just drop the link in the chat. That's weird. I'm going to drop that link in the chat. Sorry about that, William. It's pulling up for me. Is anyone else saying, I found a typo in the notes. And so around 8 a.m. this morning, I refreshed it. Sorry. And Haya, so you have posted 2 test 1 grades or current overall average seems wrong. Are they calculate? Let me double check that real quick. Only one of them should be counting, but I might have made a mistake. So let me double check. I'm not sharing my screen, am I? No. Okay, give me 1 second. Calculating overall average. Edit. So 10, that one's good. And then let me calculate this. I might have forgotten to change so the test 1 submission should not be counting. So I'm going to make sure that that's not being included in the grade book. So give me a sec. Secondary. It should be correct. I'll double check after class. Can you email me, Haya, to double check? The only one that it should be calculating is the one that says test 1 grade. I just looked, it looks right on my formula, but I'll double check after class. Remember that your the tests weigh 80% of your overall grade. That's set by the business calculus committee. I didn't make that up. All business calculuses have at least 85%. I could do more than that, but I chose not to. And then my lab math homework, that counts for 10% of your grade. And I update that after every test because it can change up until test day. So I don't have those imported into the Blackboard gradebook. I just updated your average after every test. And then your take-home quizzes, those also weigh, oops, I forgot to put the percent, 10% of your grade. Okay, any other questions or comments before we jump into today's notes? Okay, and before we move on, I just want to say one more time that if you were not happy with your test grade, don't let it hold you back. Never let a bad test grade hold you back. I know it feels awful. I know it can be defeating and deflating, and it's just a horrible feeling. I had to take algebra twice once upon a time. And when I bombed that first test so badly, I let it hold me back instead of pushing me forward. So never shy away from a bad test grade. Just have an honest moment with yourself, really pinpoint why that test grade happened, and then just change the path towards test 2. And in hindsight, I'm glad I bombed that. Well, I'm not glad I bombed that first test, but I'm glad I had to retake algebra at some point because it set me on the path I am today. So there could be positives out of this. Oh, and I remember one more thing I wanted to mention about the section 3.5 and 3.6 notes. I mentioned this in class, but I just want to say it one more time. I had a student who went to a learning lab tutor to get help on these notes. So I just wanted to emphasize that in class, I used different notation than the standard calculus notation. I didn't use the fractional notation for derivatives. I used the prime notation. And the student was asking, do I have to use your notation? Can I do the traditional notation? And the answer is yes. As long as your notation is mathematically correct, I will count it right. But if it's something we're not doing in class, you just need to make sure you show all the steps just to know, so I know you understand the concept and you're not copying it off an app or something. So for example, with that function I had written earlier, oops, it's supposed to be squared. This function that we started, if you remember, both x and y were functions of time. I just used x prime and y prime to indicate the derivatives, but what you would really need to do is use your derivative notation with respect to time for each of these, which is 100% mathematically correct. This is what a tutor would typically do, and I used to always teach it that way because that's how you teach this, and students would just bomb miserably on the tests. And so I started using this new notation and things went so much better for students. So that's why I switched to this different notation. But if you want to use the more traditional fraction notation, that is totally okay with me, and I will count it 100% right as long as you do it correctly. And that's the way my math lab's going to use it. That's the way a STEM calculus tutor would do it. This is how we do it in our STEM classes, but 1325 is non-STEM, so I'm trying to be a little less technical with that notation there. I think that's all my announcements. I don't know. I've had so many emails between now and last time I saw y'all. Okay, so I'm going to pause for one more minute, see if there's any questions. Is anyone using that traditional notation? I haven't graded your written work yet for this. I'm just curious. So Alex is using it? Right on, right on. The tutor did on Friday. Yeah, and I used to teach it that way, but then I would grade the tests and it was like a gut punch every time because students would totally bomb these questions. And then I started doing the prime notation and it went so much better. Oh, it was confused. Yeah, so Rosa, if you have any questions on my math lab, you can click Ask the Instructor and ask me to either, can you please make a video with your notation or the traditional if you prefer that, because the help tools, I know it's a gamble using different notation because getting help might be a little harder, but I promise you when I switched to this, I saw such an improvement in the test scores. Alisar, which one hurts your brain, the traditional or the new one? Maybe I'm hurting your brains. The traditional. You weren't alone. I taught this class, it's going on 15 years now, and the first 12 years I taught this course, I did the traditional, and it was a train wreck. And then I went, I was like, you know what, this is a non-STEM calculus class. I'm going to break the norm here, break away from the norm. And it seems to go better, except for that one little caveat of getting help is slightly trickier. So reach out to me for help for sure. And I also added some videos in Blackboard. Let me show y'all just to remind everyone that this is a resource. Don't look there. Whoops. I was checking that score there. Okay. So when we, when you go to Blackboard and you come down to get help under the homework help link, there's video solutions that I've answered, to email. Some of them are PDFs, some of them are videos, but I added some more for this material, 3.5 and 3.6, some more in there. I'll keep adding if I keep making them. But these have the notation I used in class. Okay, if y'all have any other questions, just don't hesitate to email me. We do need to get started on today's notes. Let's see, so let's pull up those notes. So deep breaths. You got one test under your belt, 2 more to go, y'all. Let's see if this works. Okay. Oh, give me 1 second. Don't look at that. That's messy. Don't look at that. I was making some, 1 sec, y'all. I forgot I had to restart this. Getting behind the scenes view here. 3.7. There we go. Okay. 3.7. Elasticity of demand, y'all. I'm going to send out a quick poll because I'm just curious. Okay, the poll's going to ask, have you learned about elasticity of demand in a non-math class? I'm just curious if anyone has talked about this before in a business class or maybe an economics class, this idea of elasticity of demand. Okay, so far 8 people have learned about this in a non-math class. Wow, okay, so more have heard about this than not. Okay. Oh no, Alisar despises elasticity. Joss learned about it in their previous calc class. Okay, cool. Okay. I am not an expert on elasticity of demand, the business side whatsoever. I can do the calculus all day long, y'all. But I'll just be blatantly honest. When I first started teaching this, I just had to Google the heck out of it and learn about it. So if anyone wants to chime in with any details from the business side or the calculus side, please feel free at any time. Just chime away, y'all. And I did make a video, and I linked it in the calendar to watch before class, that explains pages 1 and 2. There's no calculus in page 1 and 2. Page 1 and 2, those are like the business ideas. We're going to talk about them briefly, but if you want more more in-depth conversations about that, you can watch that video. we're going to work the calculus, pages 3 through 6 in class. But real quick, what in the world is elasticity of demand? In this class, it's a calculation. It's a calculation you will need to interpret. This formula right here will be given to you on the test. So this will be given on test 2. You do not need to memorize that sucker. You just need to know how to use it and how to interpret it. Okay, so you're going to do this calculation, which I'll show you how to do in a minute. We can see the calculation involves a function and its derivative. So we're going to have some calculus in this calculation. But when you do that, you're going to get a value. You're going to get a number. Has to be a positive number. If you get a negative number, you're going to know you messed up. And that number falls in one of 3 cases. So if that calculation you do is between 0 and 1, some decimal number between 0 and 1, you're going to be in a situation that is inelastic. The demand is going to be inelastic. So you're going to have a price-demand equation. You've seen those before in class. It's an equation that relates demand and price. If you know a certain price, you can figure the demand at that price. If you know the demand, you can figure out the price at that demand. They're connected. So you're going to use that to do the calculus to get this calculation. And if your number falls between 0 and 1, you're inelastic. That means that for a change in price, there's going to be a very small change in demand comparatively. And in this textbook, they're always going to assume that price and demand work in opposite directions. Like if price goes up, demand's going to go down. I know that doesn't always happen for every product. That's just what your book assumes. As price goes up, demand goes down, and vice versa. So they just default to that idea. But what this means is change in price. Let's say that your price is going to increase 10%. Then a relatively small change in demand means that that's going to cause the demand to go down, but less than 10%, maybe 2%. And we use percent to describe it instead of a unit because price and demand have different units. Price is dollars. You know, demand will be whatever item you're making, calculators or, I don't know, cell phones, whatever. So that's what it means to be inelastic. Your price is going to go up by a certain amount and the demand just changes a little. It goes down, but not very much. And examples of that are products that we need, right? So for example, gas, especially in Texas, we need gas to get around, right? If the price of gas goes up, demand is going to go down, but just a little. Yeah, and certain types of foods, right? Like milk, right? If the price of milk goes up, demand's going to go down, but just a little, because those are things that we need. People are going to buy them regardless of the price. They just might ration it a little bit better or something, so the demand will go down a little bit. But so the elasticity, think about an elastic band, a rubber band, how stretchy it is. If it's inelastic, it's not very stretchy. That means price and demand don't pull apart from each other very much. Oh, I need to go get my power cable real quick. Hold on. I have to plug that in. Woo, okay, I beat it before it went black. Okay, now the other situation, if you do the calculation and you get a decimal number bigger than 1, then you're going to be elastic. Elastic is stretchy. They really pull apart. That means that change in price is going to make a big change in demand. So for example, if your price goes up that 10%, maybe demand is going to go down 30%. Like a big drop in demand. That's elastic. They're really pulling apart from each other, right? And examples of that are things like clothes, where there's a lot of options out there. If you have a favorite pair of jeans or something and the price goes up, there's other options out there. Just you can buy another pair of jeans, or, you know, that's not as, it's not like you're going to have to buy it no matter what to make your life function normally. You have other options, so the demand can go way down if that price goes up. And then if your calculation comes out exactly to be 1, we call that unit demand. That just means if your price goes up, say 5%, then your demand is also going to go down 5%. They change the same way. That's unit demand. That's if your calculation it comes out to be exactly 1. And the video I posted goes into a lot more detail than that. We're not going to do that in class, but let me just pause here. Are there any questions, big picture ideas about these business concepts? We haven't done any calculus yet. No? Okay, so in the video, it goes through and it talks about how to look at that graphically, just because the calculation involves derivatives. Derivatives have to do with slopes. So you can watch the video for that little explanation. The video also shows a thought experiment talking about revenue in the context that you're used to. So remember, revenue is the number of items you sell and the price per item. It's your X and your P of X. That was on test 1. So the video kind of gives another example of something you've already seen before, but we're just going to focus on the new stuff. Okay. Oh, and there's a diagram we're going to talk about too in the context of revenue in a minute. So the video talked about all that. We're going to jump over here to page 3. This is where we are going to start today, y'all. Ready to do some calculus? Oops. Get that back up there. Okay, calculus time. So all of this is just for us to reference later. What is the calculus going to look like? Let's look at number 1. So number 1, we're given this price-demand equation. Okay, so remember, before you ever look at an equation, you got to slow your brain down, think about inputs and outputs. So the way this function is written, we input price. That means price is your input variable. And in this problem, if we do this calculation, if I plug in the price and do the calculation, it's going to output demand. So that means demand is a function of price, right? So demand is a function of price. Okay, and we are being asked to do 4 things. The first thing is just find E of P, do that calculation. So I'm going to rewrite my formula here. E of P equals what? Okay, well, the formula has a negative built in, and it has the P built in. P is your price, right? Here it's just a generic price. Then it has F prime of P in the numerator and F of P in the denominator. So F of P is your original equation. And then the F prime in the numerator, that's just a derivative of it. And we were super lucky in this one because it gave me F of P. And the next problem we do, we're going to have to rearrange some stuff to get what we need. But we were just given F of P, so that was nice. So what I like to do first is just find the derivative of that, and then I plug everything into this formula template. So let's go ahead and do that. So F of P equals this rule. Okay. And remember, from now on, when you take a derivative of something, you have to ask yourself, is this letter acting like a variable, or is this letter acting like a function? Or you can do the traditional notation, and then you don't have to think about that. So in this case, we know that P is the input variable, right? So in that case, the derivative of a plain old variable is just going to cash in for a 1. If we saw an X, the derivative of X would not be a 1. We just keep the X prime notation, but we don't have any X's in our rule, so we don't have to worry about that. But in this case, P is a variable, so we'll keep that in mind. Let's go ahead and take our derivative of this function. Okay, so we start off with a constant. We know what the derivative of a constant is, no matter what. That's going to be a 0. And then the second part, this is set up for our power rule with chain rule. Okay, so I drop my exponent down to the front. I rewrite the base. I decrease the exponent by 1, and I tack on the derivative of the base. Okay, so let's go ahead and clean that up. So it's going to be 0 minus 2p to the first times p prime. Ooh, we don't want to write p to the first, though. That looks confusing. And then p prime here, we know this is just going to be a 1 because p is a plain old input variable. What? Okay, so here we go. So what is my derivative? It's really just going to be minus 2p. So that's calculus you've already seen. We're just using it in a different way. What we just found, f prime of p, is going to go in the numerator up here. So let's go ahead and do that. Let's plug it in. Let's find my E of p rule. So this is part A. So E of p, what is that? It's going to be negative p times the derivative we just found, which was negative 2p. That was that derivative. And then in the denominator, we're just going to put the original function back in down here. So the original function that was given to us, that was the 1875 minus p squared. Okay, we can clean that up and simplify that. So a negative times a negative will give me a positive numerator. So that's just going to be 2p squared. And then in the denominator, I'm left with this rule. And there's nothing I can do to simplify that. Even if we could simplify it, I'm fine if you don't. My math lab always simplifies fractions if it's possible, but for this particular application, it does not matter if we simplify or not. But this one doesn't simplify. There's no GCF in the denominator I can pull out there. I can factor out of that binomial, so we don't worry about that. This is my E of P rule. That's the calculus part. So show me a status. How are you feeling on just doing the calculus to find this rule, to use this formula? Show me a status. Are there any questions on how I found the derivative or how I plugged it into the formula? Ah, good question, Andres. Andres is asking, how did I get it to be positive? There's a, oops, that's my subtraction tool. Put that aside. There is a negative built into the formula. So this negative right here is built into the formula. And then it just so happened that my derivative had a negative also. Yeah, so I had a double negative. Yeah, cool. Any other questions or comments? Okay, because now we're going to use this. We did all that calculus. Now we're going to interpret. There's not too much to interpret on this one. Just plug and chug, but let's do it. Okay, so we're going to do 3 different scenarios. For B, we're going to find E of 15. For C, we're going to find E of 25. And then for D, we're going to find E of 40. Okay, so let's go ahead and do those 3. This is just plug and check. This is just algebra, right? So I'm going to take this rule up here and plug in 15. Let's see what we get. Ooh, I'm going to have to round. Oh, they don't have D? Okay, that's okay. We don't need to do D. This is just plug and chug. We could do it for fun if we wanted to. I need to go check that, though. Thank you for telling me, Rosa. Let me write that down on my to-do list. I was cutting some stuff just to make sure we get everything done we need to do today, because I knew we'd have to talk about we needed to spend some time talking about the test. Okay, can anyone confirm 0.27? Did anyone else get that? Let me type it in again. Oh, good. Okay, cool. Awesome. So what does that mean? We need to interpret this. Yeah, which of the three cases does this fall into? So I'm going to go back up to my cases. So I have 0.27. Here are my three cases. Yeah, it's inelastic. 0.27 is between 0 and 1. That makes it inelastic. So I need to come back here and say this was between 0 and 1. This is inelastic. So I would say at a price of $15, because remember, we're plugging in a P. We're plugging in price. So when the price of this object, whatever it is $15, the demand is inelastic. That means it won't change very much based on the price. That right now, all you need to know is that it's inelastic. Later, we'll see how to go one step further. We're just practicing the calculations right now. So I'm inputting a price, and my output, all it's telling me right now is that it's inelastic. And we'll just do one more here. Let's say, what if the price was $25? What would that do? What scenario would we be in? I don't know. Let's plug it in and see. E of 25. So 2 times 25 squared. Oops. 1250. Ooh, 1250 over 1250? That's equal to 1. Need to interpret that. Go up to my three cases. If it's equal to 1, that's a unit demand. That means the price and demand will change the exact same way, in opposite directions usually. When I say the same way, the same percentage, but in opposite directions is what your textbook is going to assume. So this would be, my interpretation would be, at a price of $25, the demand is a unit demand. So that just means they're going to change the same way, right? If demand goes up, if price goes up 3%, demand goes down 3%. And 40 came out to be elastic. It's just plug and chug, so we won't spend our time on it since it wasn't in your notes. Oops, not in notes. Doesn't matter. It's just more of the same. We'll see that in number 2. Okay, let's kick it up a notch. Oh, any questions on how to interpret these at this point before we take it one step further? I'll shrink this while we wait. Okay, then let's see what happens when we add a layer. At any point, y'all remember, I know it takes some time to type. You can just unmute and say, hey, Kelly, I have a question, or hey, Kelly, I'm typing a question. Okay, what in the world is this problem asking? It says, suppose the price, P dollars, and the demand X for a certain product are related by this price demand equation. So see how this is implicit? The other one was explicit. We already had one of the function simplified on one side of the equation and then the variables on the other. This is implicit. But luckily we can do some algebra on this one to make it more user-friendly. We're being told to first express the demand as a function of price. That means to get X to be a function of price. That basically means to solve for X, which we can do algebraically. You could also do implicit differentiation if you wanted to. And the reason why I need to do that is when I go to do my elasticity calculation, remember the rule, the formula that we're given says it has an F prime of P in it and an F of P, like it has to be in terms of P. That means we need to get our X to be a function of price, where we plug in a price and get a demand. That's how you're going to interpret that. So the first thing we need to do is take our price demand equation, currently implicit, and make it explicit. This is just algebra, no calculus happening. I'm just going to subtract the 500p on both sides. So I have 10,000 minus 500p. So if I rewrite this with function notation, it would look like this. This is telling me if I input price into this rule that we're going to calculate demand, right? That's going to be my output. Demand is a function of price here. Oh, and it's asking us to state the domain. That can be kind of tricky. But before I do that, any questions on just rearranging this? Why solving for X makes it a function of price? Okay, the domain is actually going to be a key piece of this problem later. So taking some time to talk about domain will help us with answers down the line. So let's talk about that. Remember, domain, the domain of a function has to do with the inputs, right? The domain are all the inputs allowed into the function. And what are we inputting? Price, right? We're going to input price. So I need to have some restrictions on price. There's going to be a lowest price and a highest price. What's the lowest you can price something? Yeah, $0, right? It's free. So the lowest it could be would be $0. You can't have a negative price. That means they're giving you the object and money on top of that. Those ultra couponers, right? They get it for free and then they get cash back. But in this, we're always going to assume the lowest the price can be is 0. So I already know one restriction on my domain, but I need to have an upper limit. It can't be infinity dollars. How are we going to find that domain restriction? Well, it comes from the idea that demand, the number of items demanded, also has to be greater than or equal to 0. We can't have a negative demand. The lowest, it could be a 0. If no one is buying it, if there's 0 demand, that's the lowest we can go. So what we're going to do is we're going to take this rule for demand. Yeah, so the lowest demand can be a 0, Josh. The lowest, you cannot have a negative demand. If you get a negative demand somewhere, you messed up. Same with price in this scenario. If you get a negative price, you know you messed up somewhere. So that's kind of a good check here. Since it's in a scenario, a real world scenario, we're always going to assume the lowest you can price an item is $0 and the lowest the demand can be is X items. So I should put X items. Well, let's just put 0. Ooh, 100,000 at equilibrium. Yeah, so Here's the trick. I got some good ideas out there. We know the demand is this rule right here that has a P built in. So the demand X can be replaced, it's equivalent to this rule, 10,000 minus 500P. So that has to be greater than or equal to 0. Oh, you're close, Blue. Off a couple zeros, or 1 0. You're just going to take your rule for demand, which can be replaced with this binomial, and set that binomial greater than or equal to 0. And then it's just algebra. There's lots of ways you can solve this. I'll add 500P to both sides. So if 10,000 has to be greater than or equal to 500P, there you go. Yeah, 20. Nice, nice. Just divide both sides by 500. So 20 is greater than or equal to the price. So that's my upper limit on my price here. I'm going to come up and say the price can be at most $20. This scenario will only work for prices between $0 and $20. You can't go above $20. So keep that domain in mind when we work future problems. So if they asked you to find an E of 30 later, that's undefined. Like I can't do it because 30 is not in the domain. Okay, so let's move on to part B. Now that we have our function, we can find this calculation down here. So let me rewrite what my function was. I already forgot. Okay, so f of p was 10,000 minus 500p as long as the price is between 0 and 20. Okay, that's what we got from the previous problem. To find E of p, we need to know the derivative of that. So I'll just find that derivative really quickly. If you're really savvy with your algebra, you'll recognize that this function is in y equals mx plus b format. It's linear. And that derivatives are slopes, the rates of change. So the rate of change is negative 500. So if you know shortcuts like that from algebra, that's totally fine. If not, you'll just use your power rule. I won't do that now because you can do that on your own. But when you use your power rule, you're going to get the derivative is negative 500. Okay, so let's go ahead and do our calculation. So what would my E of p be? There's a negative built into the formula, a price built into the formula. Then I do the derivative of my function, which we just found. That was negative 500. And then we do the original function, which was this rule up here. 10,000 minus 500p. Okay, so we can clean that up a little bit. A negative times a negative will be a positive 500p in the numerator, and we keep our denominator. Okay, so you can stop right here and get all of your points. But my math lab is going to simplify that fraction. So any ideas on what I could do to simplify this fraction? Right. Divide it all by 500p, factor out the, oh, not the p, just the 500, right? Yeah, we can't just straight up, we can't just straight up cancel those out. We have to factor, then reduce. I know it's really tempting to cancel those out, but there's no p in the first term, so can't do that. This is why I'm happy, like, that's a happy fit. I promise those are happy. Oh God, he looks not happy. Let's try. Is that happier? This is why I'm happy if you stop here, because the algebra is where people mess up. So what you would need to do over here is factor out the 500 only. So this is what my math lab is going to do. In the denominator, it's going to factor out 500. It always factors out whatever's in front of the P. It doesn't even factor out a GCF. It's really wonky. So there was a 500 in front of the P, so they factored out. So 1,000 divided by 500 is 20, minus 500 divided by 500 would be 1P there. And then the 500s will divide out. So my math lab is going to write this as P over 20 minus P. But again, I don't care. It's safer to stop over here, because then you don't have to mess up like on algebra. Yay, algebra. Okay. So any questions on that one? Any of the algebra or calculus we did there? Okay. We're going to move on to C here. C is asking us to do a couple of things. Oh, I heard a little chime. Oh yeah, the tool. I know. I did not give y'all enough room to write on here. Don't you wish you could do this in real life? Just shrink whatever you wrote on your paper. That would be nice. See, technology, there are some advantages. Way before the pandemic, in class, I didn't write on the chalkboard. I would write on I'd project this up on a screen and write on it, just so I could save what I wrote for students, posted in class. Obstacles, yeah, no, it's very nice. Okay, well, let's look at C. Okay, what is C asking? C is asking us to find values of P. That's prices, right? So find prices. For which demand is elastic. Demand is elastic. Well, that's when your calculation, your E of P calculation, is greater than 1. That's what makes it elastic, right? Learned elastic is when you do this calculation and you get a value bigger than 1. And then we're supposed to find prices for which the demand is inelastic. That's when your calculation is between 0 and 1. Now, here's the thing. You only have to find one of those, because you're either elastic or you're not, right? Or you could be unit if you're right on the line. So we'll talk about that too. But you only have to do one of these, and then you can use logic to figure out the other. So I think it's easier to find where things are elastic, and then we'll use that answer to backtrack to where it's inelastic. So let's start with this calculation. Something is elastic if the E of P calculation is greater than 1. So what we're going to do is we're going to replace this E of P calculation with the rule that we got up there. So how do we find E of P? We do 500P, or you know what? Since we did all the work to simplify, we might as well use the simplified one. That's probably nicer. It doesn't matter which one you use. You can use either of these. Okay, so we're going to solve this inequality. So this is just algebra, no calculus happening here. Okay, I'm going to clear the fraction. So I'm going to multiply the left-hand side and the right-hand side by the common denominator. So those will clear and leave me just a P. So P is going to be greater than 20 minus P. Okay. And then I'll just get all the P's on one side. Do that different color. Okay, so now I'll have 2P is greater than 20. So I divide both sides by 2. So this is going to happen when P is greater than 10. So this means demand is elastic for prices greater than $10. Okay, and I box that on a test or a quiz and I get it wrong. Or I type this into my math lab and I get it wrong. It's half right. There's something missing. Does anyone know why this is partially incorrect? What does P greater than 10 mean? Could price be, 1,000 is greater than 10. Could my price be $1,000? Yep. Good job, Alex. They are right. The price, remember our domain? The price has to be between $0 and $20. So if I just left my elasticity as greater than 10, you're assuming it could be 1,000 or 1,000,000, or we have to cap it. So when I go to say for prices greater than 10, I'm going to get points off. I need to say for prices greater than 10, but less than 20. Technically less than or equal to 20. We don't want to say less than or equal to 10 because when P is exactly equal to 10, that will be your unit demand. So if you're exactly equal to 10, you're in your unit demand. If the price is greater than 10 but less than the domain restriction, that's going to be elastic. So then by default, the other one will be inelastic. We know price has to be greater than or equal to 0, but it also needs to be less than 10. That would make it inelastic. That's our only other option left over, right? Just using our calculation for elastic, we can figure out the rest must be inelastic. All of that was algebra. That was calculus. So I'll just pause real quick. Any questions on that? And if you wanted to, if that logic was too big of a jump, you could just redo the algebra. You could start over here and you could put your rule, your P 20 over P, greater than 0 and less than 1, and do the algebra on this, and you'll end up getting this interval right here. If you want to do that algebra, it'll totally work. Or you could do logic. I don't care. As long as what you write down is mathematically correct, and it's what we're looking for, I don't really mind how you find it. Just remember, if you use a method different than what we used in class, you just have to show all the steps to make sure you're not just copying off an app or something. Okay. This problem has like 4 more parts. So any questions so far? Just show me a status. How are you feeling so far on this idea of elasticity, of working with this formula, of thinking about restrictions on price or what makes something elastic versus inelastic as far as calculations go? Like, I don't know yet. I mean, yeah, you need to practice more. If you're feeling like, what? That's okay. You're going to feel that way 90% of the time in class. Amanda, you too? That's okay. 90% of the learning happens outside of class. We lay a foundation. We give you some notes to fall back on, a video to rewatch. The real learning happens when you're out of the classroom. I can't take credit for it. I wish I could. If you got an A on test 1, I wish I could say that was all me, but it's totally not. You would have gotten an A no matter who your professor was, because that learning happened outside of the classroom. But anywho, okay, so let's look at D now. What is D asking? D asks, what is the elasticity of demand when the price is specifically $4? And then there's another part of the question, but let's start here. First of all, we're just going to use our calculation and plug in a 4. That's it. Price is 4, plug in a 4. So we're going to plug in P equals 4 to my elasticity rule. I'm going to use the simplified one since we went to the trouble of finding it. So wherever there was a P, We're going to replace it with a 4. Okay, so that's going to give me 4 over 16, so that is 0.25. Ooh, you have to find out which of the 3 that is. Well, that case, it's between 0 and 1, so that's going to make this inelastic. 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 So at least we know what scenario we're in. And if you know what inelastic means, you know that your change in price is going to cause a small change in demand. That's what it means to be inelastic. So now we have to do this next part of the question. If this price, so if P equals $4, increased by 10%, you don't actually have to do that calculation. You just have to know that price went up 10%. If you want to actually calculate that, you can. The new price would be $4.40 if you really wanted to find 10% of $4 and add it back on. You don't have to do all that. We just need to answer this question. It doesn't say what is the new price, right? It says if the price increased by 10%, what is the approximate change in demand? So what we do is we use this elasticity calculation as a multiplier. What do I mean by that? I mean we take that calculation and we multiply it by that increase of 10%. And that tells me that my demand is going to do the opposite in this book. It always assumes the opposite. Well, opposite of what? When I multiply these, when I do my multiplier times 10%, that's going to give me 2.5%. That's what makes it inelastic. A 10% change in price caused a smaller change in demand. A 10% price increase, but only a 2.5% demand decrease. A small change in demand. How are we feeling on that? Any questions on how I used that elasticity calculation as a multiplier? I multiplied it to the percent, and that 10% was just given to us, right? That 10% was given info. This was my E of 4 over here. So if they had said the price increased by 5%, I'd multiply 5% by the 0.25. If they said 3%, I'd multiply 3% by 0.25. No. Well, now let's see what happens to revenue when this is going on. You're going to be given this diagram exactly like you see it here. So this is going to be given on test 1. You just need to know how to use it. So let me write that on there. This is going to be given, test 2, on test 2. You just need to know how to use it. Okay, so this diagram is just a way to organize information to think about revenue. So when I look at this diagram, I see I have price on my x-axis. This is price. That's my input, right? Input goes on the x. And then my y-axis, right here, I'm calculating my revenue. So revenue is on the y-axis. Price is on the x-axis. So this curve right here, this is my revenue curve. Revenue goes up, it hits a max, it comes down. And that curve gets cut in half in the diagram. So wherever it's cut in half, that's your unit price. So this is going to be that unit demand price. You don't Need to know what that number is? You just have to know, is your situation elastic or inelastic? So let's go back up to that $4 and figure out, are we on the elastic side or the inelastic side? So let me shrink this up real quick. I did not use that very well. A little bit more. Okay, so we're looking at $4, right? Because it's saying if P equals $4, so you have to ask yourself, was $4 elastic or inelastic? Well, when I come back and look at that, it was inelastic. If it was inelastic, that means we're going to be on the left side of this diagram somewhere. We don't even care where. Just somewhere there, we're going to be on the left side of that diagram. So I marked a generic point here, right here. Let's say that this was my $4. It doesn't even matter where it is. It just has to be on that side somewhere. Okay, it says at this price, if the price decreases, will the revenue increase or decrease? So right now I'm at $4. If I decrease that to maybe $3 or something, if I decrease the price, what's going to happen to the revenue? Well, it's going to drop to get to, remember this curve right here, this is showing my revenue, all the revenue values. So if I decrease the price, I have to go down to hit the revenue curve. So my revenue also decreased. If I decrease the price, my revenue is going to decrease. So I decrease the price, my revenue is going to decrease in this case. So if $4 is decreased, the revenue also decreases. And that's just from reading that graph there. Just reading that diagram that'll be provided will help you think about it, because it's a kind of complicated thing to think about. So decreasing your price is going to cause demand to go up. Remember how they act differently? So decreasing the price is going to make demand go up, but not by very much. So the demand increase isn't going to offset the price decrease. You're selling more things, but for less money. And it wasn't enough to increase your revenue. That's what's happening there. Because remember, these act differently. So if your demand was increased by 2.5%, your price is going to decrease. They act opposite. So decreasing your price does demand go up, but not enough to make a difference and to increase your revenue. You're just going to bring in less money overall. But that can be kind of hard. Those business concepts are kind of deep. So you can just read this diagram for now and figure out what the answer to the revenue is, and then fill in the blanks with the business aspects as you go. We're just practicing reading this diagram right now. Let's try another one. Let's do another one here. Sometimes you got to do a couple examples before it starts to sink in. What is F asking us? F says, what is the elasticity of demand when P equals 10? I don't know. Let's plug it in and see. Let's plug a 10 in there. So the rule was P over 20 minus P, right? That was our generic rule. And now we're just going to plug in a price of 10. So let's, everywhere I see a P, I put a 10. Okay, that's going to give us 10 over 10, which is 1. That's your unit demand. So what does that mean? That means if your price is increased by 10%, well, if my multiplier is a 0, right? This is, I'm sorry, is a 1. This is my multiplier. If I times that by 1, doesn't it just stay 10%? That just means my demand is going to act opposite. So our book assumes it's going to go down, but it's still just going to go down by 10%. Change the same percentage, just opposite directions. And you won't be asked what the revenue is doing there. So don't worry about that part. But let's do another one. Let's do an elastic situation, so we can read the graph on that elastic one. So let's try this one. Now plug in a price of $16. That would give us 16 over 20 minus 16. That would give us 16 over 4. Ooh, whoa. 16 divided by 4 is 4. That is hugely elastic, very elastic. Multiplying something by 4, quadrupling it, that is super elastic. Super duper elastic. Let's try that. Let's do that. If my price increases by 10% and I use my calculation as a multiplier, woo, what does that do to my demand, y'all? My demand is going down a huge amount, down 40%. That's huge. That's super elastic. And we're going to analyze that on the graph here in a minute. Before I do that, are there any questions on the ooh, okay, Josh, go ahead.
Can you hear me?
Yeah, go ahead.
So I work at this restaurant called All Star Burger in the Galleria, and
Okay.
we've been using this one mayo for like the longest time, and that company decided to double their price. So we basically just switched vendors because the price went from like $2 to $4 per like.
Whoa.
So our demand for it just went to zero because it costs so much now.
Exactly. And mayo is one of those elastic situations where there's a lot of other kind of mayos you can use, right? So y'all, it wasn't like you had to really think about that decision. You're like, next, mayo. So yeah, the demand goes way down. That's a great example. Awesome. Thank you for sharing that. Ooh, God, it makes me want to do the math on it. I want to like get all the numbers, but I'm not going to. Y'all don't get excited about that. Didn't make you want to just whip out some calculus? No?
I can ask my manager for the prices and ask you to crunch the numbers.
Oh, I would love to. That's fun for me.
I'll send you an email if he responds.
Sweet. See, guys, when am I ever going to use this? When you have to run a restaurant and the price of mayo goes up. No, I'm just kidding. I know that like your boss did not think about calculus for 1 second when he was making that decision, but whatevs. We're in calculus land right now. Okay, so let's talk about the revenue on this, because this is what really gets people. People can plug and chug these numbers. They can say it's elastic and elastic. What does that mean? The reason why economists do this is to think about revenue, right? Or businesses want to think about revenue. They want to think about profit too, but we're just thinking about revenue right now. So if P is 16 and the price is decreased, what's going to happen? Let's plug it in and see. So all we need to know when P is 16 is ask yourself, is P equals 16 elastic or inelastic? Because you need to know what side of the diagram to be on, right? Well, we found that it was very elastic. Yeah, it was super duper elastic, right? So this was very elastic. So that just tells us we are going to be on this side of our diagram. It doesn't matter where, we just have to be somewhere over here. This just helps us read it. Yeah, and our calculation was way over 1, so super. So yeah, we're in this elastic side, and it doesn't matter where, but I put a generic point here. So let's just pretend that this is our price of $16. Okay, and we are told price decreases, so we're going to go back on our price. If price decreases, I have to go up to hit the revenue curve. So that means my revenue is going to go up. It's going to increase. So let's think about why that's happening. If the price decreases, the demand is going to increase by a lot, right? So it's going to do, if the price decreased by 10%, let's just say instead of increasing, we were decreasing, the demand's going to increase 40%. So even though you're selling them for less, you're going to sell a whole bunch more of them. So that's going to raise your revenue. That's the idea there. So I'll change it back to this scenario. But that's the idea. Decreasing the price in this scenario increased your revenue. In the other scenario, decreasing the price decreased the revenue. In this scenario, decreasing the price increased the revenue. You just have to think about the scenario. And these business concepts, like I said, take time. Luckily, you'll have the diagram to reach onto if it's not, the business part isn't sinking in. But I would say for my answer here, if $16 price decreases, revenue will increase in this case. I drop the price, but I sell way more of them, so I make up the difference. And then some. Okay, awesome. We are right on track for where I wanted to be because we're just going to start the next set of notes. Are there any questions on this idea of decreasing the price, increasing the revenue before we do our last problem in these notes? Okay. Got one more price. Ooh, hamburgers. I should change this to mayo. Oh well. It's about hamburgers. Okay, let's look at 3. The price demand equation for the sale of hamburgers at a fast food restaurant is given by this equation, price demand equation, where P is the price per hamburger and X is the number of hamburgers sold daily. Okay. The current price of a hamburger is $4. In order to generate additional revenue from the sale of hamburgers, would you recommend an increase or decrease in the price? So the company is trying to decide, should I increase our price or decrease it? How's that going to affect demand? Do it. Increase the price. Well, let's let the calculus decide, right? Is it elastic, inelastic? Was it? We don't know until we do crunch the numbers. Notice how nowhere in here do we see the word elastic. Nowhere in here do we get a hint that has the E of P notation. You'd only know that right now is if you were in section 3.7, you'd be like, of course it's elasticity. So like on your homework, it's going to be like, duh, it's elasticity. But on a take-home quiz where things are mixed up, you might be like, what do I do with this? So I'll probably on a test be nice and say like section 3.7 or something to help you out here. Because nowhere in here do you see the word elasticity. We just have to know that. Okay, so here we go. So we need to do a couple of things. The first thing we need to do is rewrite equation to be the X equal F of P, right? We need to do that. Because the second thing we need to do is find the E of P calculation, right? At P being $4. And that'll tell us whether it's elastic or inelastic. And then that'll tell us whether we should raise the price or decrease the price. Okay, so let's go ahead and do all that. Okay, so let's take our equation and solve for X. That's easy. We'll just subtract 400 on both sides. So X will be 3,000 minus 400P. So I could rewrite that. This is a function of price now. If I plug in a price, it'll calculate this demand. So if you want to rewrite it with that notation, Oops. You can totally do that. Okay, so now we can find E of P. Oh, wait, we need to take the derivative of that real quick, right? So let's do that. Hopefully you can just look at this and see that the derivative is negative 400 because, again, this is in y equals mx plus b format, where your slope, your rate of change is negative 400. But if you don't see all that, just do your power rule with chain rule, and you'll get the derivative is negative 400. So now we can go do our formula. Okay, so now I can plug all that in. So there's a generic negative, a generic p. What was the derivative for 100? Negative 400? Okay. And then the original function, once we solved it, was 3,000 minus 400p. Definitely want to clean that up. So in the numerator, we have a double negative again, so that'll give you your positive 400. Boom. And I'm just going to stop there because we don't need to be a hero. Let's not get lost in the algebra. I'm going to stop right here. I'm going to show you what my math lab does. I don't like it, but I'm going to show you what they do. Just in case you're using the help tools, I don't want you to freak out. So on my lab math, this is what they're going to do. They're going to keep the numerator the same. And in the denominator, they're going to factor out the 400. Whatever is in front of the p in the denominator, they factor that out. So you do 3,000 divided by 400, and that comes out to be 7.5 minus, 400 divided by 400 would be 1p. Instead of factoring out a GCF, they factor out whatever coefficient is in front of the p, and then they divide those off. So my math lab would end up using p over 7.5 minus p. And you can use that too if you want. It's just chances of you messing up that algebra are pretty high. So I'm just going to use the unsimplified one. And I'd get the exact same answer as if I use the simplified one. It doesn't matter which one you use. So I'm not going to take a chance on the algebra. I'm just going to find E of 4 now. All I need to do is plug $4 into my calculation. I don't know what that is. Calculator. Here. Okay. Ooh, thank you, Alex. They already did it. So when you calculate that, either one you use, you should end up with 1.14, which is elastic, right? So I'm going to write this down. 1.14 is greater than 1, so it's elastic. That's the key to figuring out whether they should increase or decrease the price to increase the revenue. So I'm going to come draw that out. Remember, this sketch will be given to you. You'll be given this curve cut in half, and you'll be told that this side is inelastic and this side is elastic. That's what you'll be given. And we just figured out it's elastic, so we need to be on the right-hand side. So I need to be over here. Anywhere over here will work. So my price of $4, let's just say it's here, it doesn't matter. Let's go up and put it on the graph. Okay, what were they asking us? I already forgot the question. If the current price of a hamburger is $4, oh, in order to generate additional revenue. So they're saying they want to increase revenue. They want to increase the revenue. It's asking what should they do with the price? So looking at this, what should they do to, if they want to increase the revenue, what should they do to the price? That's right. So now they should decrease the price, right? I kind of sketched that. Oops. Oh, wow. I did not mean to erase that whole thing. Okay, give me 1 second. I'm going to move this over. Oh, sorry. Okay, I'm going to move this over just because it doesn't matter where I am, just to help me read it. You're right. If I decrease the price, so decrease price, then I go up to hit the revenue. So that will increase my revenue. If I increase the price, I decrease the revenue. If I increase price, I go down on the revenue. We don't want to do that. We don't want to have to go down to hit revenue. So maybe I'll draw that and say, this is what we don't want to do. So you would recommend a decrease in the price. So I would say, since demand is elastic at $4, a decrease in price will increase revenue. Oh my gosh, that was a lot of stuff all scribbled on my screen there. So these problems take a lot of time. As you can see, there are a lot of calculations going on, a lot of interpreting. On test 1, a lot of students were tripped up with the interpreting, like being able to read a function. What's the input? What's the output? What are the units for the input? What are the units for the output? You could do the calculation, but then knowing what it told you, that kind of tripped y'all up. So really focus on those interpretations, on units, inputs and outputs. Focus on that with this new material. Since this is an applied calculus course, a lot of points come from those interpretations. Where if you took a regular STEM calculus in the past, that probably was not the case. It's more abstract. This is more applied. Oh man, y'all, this class is a marathon. 2 hours of calculus. Woo! We are going to do some graphing, but let's just take a 1-minute brain break. We'll see if there's any questions. It's about to switch over to something totally different. I need some coffee, man. Woo! Okay, y'all. So just heads up, write yourself a little note somewhere. I'll write it here. We finished the 3.7 notes. So 3.7 notes, 3.7 My Lab Math is due next class, which is Wednesday, is due Wednesday the 30th. But we're going to start chapter 4 and not finish it, so that My Math Lab won't be due. So you only have one My Math Lab due on Wednesday. But it's kind of time intensive, right? So make sure you give yourself plenty of time to do that My Math Lab. Anytime we finish a section in class, then My Math Lab is due the next class. Yay, summer. God, now I want a hamburger. Okay, let's...
Then go to All-Star Burger. It's open right now.
What? I am actually not in Austin right now. That's why things have been kind of crazy. I'm in the Rio Grande Valley. I don't know if anyone knows, like down by Brownsville, South Padre Island. I came home to help oh, you were born there, Alex? But what? I was born in Weslaco. Where were you born? McGowan. Nice. Sweet. Okay, we're from the same place. Sorry. So very, very tip of Texas, as far south as you can go. I needed to come home and help see my family and help a little bit. So anyway, but I am back in Austin next week. Things will be back to norm next week. South Padre, yeah, no, super nice. Me too. Love it. Got distracted. I wish I was on the beach right now for sure. I got distracted. What are we doing? Oh, the next notes. Okay, cool. Let me pull up the next. Anyone else from the Valley? No, just Alex and I. Cool, cool. Okay. Born and raised in Austin, Texas. Right on. Right on, right on. That's getting rarer and rarer these days to be actually born and raised in Austin. A lot of implants like me. Okay, insert as a printout. Galveston, okay.
I got a beach house in Galveston, and I'm going there for the 4th.
Oh, nice. Gonna.
The Batman, they got me 2 Beyblades.
Oh, wow. Hold on real quick, guys. Yeah, nice. Okay. Sorry, Beyblades. Oh, really? Yeah, my son is obsessed, and apparently my dad just let him go to the store and get a Beyblade. So, awesome. Okay. Yay, grandparents, spoil the kids. So, let me get my brain turned on. I promise, y'all. I promise I will start functioning properly at some point. Okay. Everyone get up, stand up. Where you are, stretch. We're going to turn our brains on to graphing. We have 20 more minutes. We can do this. Perfect. I just wanted to get through the first problem. So, Alex, real quick, how old is your son? I just have to know since you said your son loves Beyblades. 6 in November. Nice. Yeah, my son just turned 7. So that's the age, apparently. Okay, so here we go. So today, and these notes, starting right now and on Wednesday, we're going to finish these on Wednesday, we are going to start connecting derivatives with graphs. We've done some of this, y'all. You found where a tangent line was horizontal by setting the first derivative equal to 0. We've done sign charts. We're just going to start connecting the dots, and we're going to add one new idea called a second derivative. Okay, so this first part of the notes is just a whole bunch of reference for you to go back to later. I'm going to talk about all this, so I'm not going to describe it. But up until now, the derivative you've been finding, that f prime, is what we're going to call a first derivative from now on. Moving forward, f prime is first derivative, p prime first derivative, x prime first derivative. Those are all first derivatives. Today we're going to learn second derivative. It's just the derivative of the derivative. That's all it is. Okay? And then point of diminishing returns and all these applications are at the end of the notes. But we're just going to start with some familiar stuff. So we're going to just skip over to page 2. This is just for you to reference later. These are all things I'm going to say. And we're going to start right here. Okay. So starting on this set of notes, you're going to have to read more carefully than you've ever read, especially graphs. So what I've done here is I've graphed this function, f of x equals x squared minus 4x plus 3. I see f of x notation, not a prime or anything weird like that. This is just your original function. It's a nice, pretty parabola. It's degree 2. It's a polynomial. So this curve right here is the graph of f of x. So always read the y-axis like it's going to be labeled. It's going to tell you what's showing up on the graph. This is just showing the original equation. This is the graph of the original equation. Later, we're going to graph derivatives. It's going to get confusing. Right now, this graph is of the original function. Graph of the original function. Okay, so what we're going to do right now is take a graph and translate it to sign charts. Now, next class, I'm going to give you sign charts and you're going to draw a graph. That's a little bit harder. We're going to take a graph and translate it to sign charts. We've already created sign charts back when we did continuity in section 2.3. We're just going to apply them to graphs. We can use sign charts for all kinds of things. We use sign charts to solve inequalities. Now we're going to use sign charts to describe a graph. So we're going to create a sign chart for f of x for this graph shown, the original function. So remember, when you draw a sign chart, all you do is draw a number line. That number line is representing inputs, special inputs. And above the number line, you're going to describe the outputs of that function with either positives or negatives. So there's a huge delay on my app right now, but that's okay. So we're going to describe outputs of the original function. So I need some numbers on this number line. There's going to be two of them, two special inputs. Can anyone look at the graph and guess what they think those special numbers are going to be, the numbers that go onto my sign chart? Nice, that's right, that's right. The partition numbers are where the function either equals 0 or undefined, just like we did on the previous sign charts, right? Remember, the partition numbers are like a gateway between positives and negatives. To go from a positive output to a negative output, you have to cross through 0. So that was kind of like a gateway. So that's what we're going to do here. We care about these 2 points. So when x was a 1, if I put 1 into the function, it outputs a height of 0. Remember, the original function is just ordered pairs on the graph, right? So I'm going to put f of x. This just gives us ordered pairs on the graph. Of the original function, right? It's just ordered pairs. So this is the ordered pair, 1, 0. So on the number line, they're just going to put a 1 below the tick mark and a 0 above. But I'm going to say what that means here. That 1 means your input was a 1. And that 0 means if you put 1 into the function, you get a 0 out. And then same thing over here with 3. When x was a 3, if I input 3 into the function, it's a height of 0. That's the point 3, 0. So they'll put a 3 below the tick mark. That means your input was a 3, and they'll put a 0 above the tick mark. If I put a 3 into the function, I output a 0. And since this was a polynomial, it's always defined. The domain is all real numbers, so those are our only partition numbers. We call those numbers, those inputs, partition numbers. They partition my number line into different regions. So now let's look at those regions. This first region right here, this is representing all the inputs from negative infinity until I hit 1. And since this is continuous, I just have to pick one test point out there. Pick any number between negative infinity and 1. So I don't know, let's pick x equals 0. That's an easy one. It's always easy to work with 0. Let's put 0 into the original function. You can either do the rule or you can just read the graph. What's the output? If I put 0 into the function, what's my output? That's right, it's 3. You can get that 2 different ways. If I look down here at 0, I can go up to the graph right here. When x was a 0, if I put 0 into the function, the height is 3. 0, 3 is the point. Or you could put it into this rule up here. I could do the rules. Either way, oops, minus plus 3. Either way, you're going to get a 3 out, right? All I care is that that's a positive output. We just care that this is a positive output, because remember that continuous idea tells me if that output is positive, all the outputs in that region are positive. You only have to test one of the inputs, but all the inputs will create the same kind of output. So this whole part of the graph right here, that's a positive output. And then I can see it switches negative between 1 and 3. If we pick any input in there, my outputs turn out to be negative. I mean, you can pick one if you want. So we could pick, I don't know, x is 2. If I put 2 into the function, here's 2. Here's where x is 2. If I put 2 into the function, I get an output of -1. But all I care is that that output is negative. Like, I don't care about the number. It's just if that output's negative, all the outputs will be negative in those regions. Then I hit 0 again, and then it's going to go positive. If I test any input here in this region from 3 all the way to infinity, if I test any of those points, the outputs will be positive in that region right there. So this sign chart is describing ordered pairs on the graph, outputs on the graph, right? So you might be asked questions like this in my math lab. So let me change the color. If it asks, where is the function greater than 0? That's just asking where the output's positive. Greater than 0 means positive. You're just going to have to slow your brain down and be like, okay, f of x is an output of the function. Greater than 0 means positive. And then you come read your chart. That's happening from negative infinity until I hit 1, and again from 3 to infinity. So we've done this before, and you should have done this in your algebra class. So none of this is calculus. It's just plugging and chugging. Any questions on how to read this sign chart or create the sign chart just for the given function, just the algebra that's happening here? And if you're iffy on this, way back at the beginning of the semester, I post some algebra videos on this. You can go rewatch those. It's with that continuity, section 2.3. Okay, now we're going to make a new sign chart, but this sign chart is going to be for the derivative. Here comes calculus. We did a sign chart for the original function. Now we're going to do a sign chart for the derivative. Sorry. So first of all, we have to find the derivative. So let's go ahead and do that. I'm going to go to my original function, and I'm going to find the derivative rule here. So just do your power rule. The derivative of x squared is 2x. The derivative of 4x is 4, so I'm subtracting 4. And the derivative of a constant is 0, so we don't really need to write that. So I did that fast. You should know power rule by now. And now we're going to create a sign chart to describe this, and then we'll connect it back to the graph in a sec. First, let's do the sign chart. Boop, 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 boop. So what numbers, there's only going to be one number this time. What number is going to go on there? Any ideas? What's my partition number this time? 2. That's right, Rosa. Why 2? That's right. Excellent. Yes, so what Rosa did is Rosa said, okay, where would the derivative, where would this rule, the 2x minus 4, where would that equal 0? That's right. And just solving this algebraically, 2x would be 4, x would be 2. Excellent. That's your partition number. I put a 2 under the tick mark to describe the input. I put a 0 above it because if I input 2 into the derivative rule, I get 0 out. Very nice. And just heads up, we could have gotten that on the graph. When the derivative is 0, isn't that where the tangent line is horizontal? And here, when x was 2, isn't that a horizontal tangent line? The derivative would be 0 there. I know that's kind of crunched in there to see, but see how that tangent line is horizontal? Because remember, your first derivative describes the tangent lines, the slopes of the tangent lines. Of the original graph. So from, let's see, from negative infinity all the way till I hit 2, just looking at my graph, what would I expect? If I cut my graph in half and I look over on this side and I pick any point, what would the tangent line, what kind of slope would it have, positive or negative? So I hear vote for positive. That means if I picked a point, the tangent line would be pointing up. The output is, the function is positive, but what about the tangent line? The tangent line is if you pick a point and do that line that hits the graph at one point. I know it gets confusing, right? The output of the function is positive, but see how the tangent line points down? The tangent line points down at any point there. So if I have a U and I pick any point there, the tangent line at that point is going to point down. Eventually it's going to hit 0. Eventually the derivative will be 0 there. But here, I don't know what the derivative is, but it's a negative number. So these should all come out with negative outputs because the tangent lines are negative. So, okay, so Blue said, oops, negative. So it doesn't matter that the output of the function is positive. We're just focusing on tangent lines. And same thing on the other side. On this, oops, on the other side of that line, on the other side of x equals 2, if I pick a point, the tangent line is going to be positive. So tangent line has positive slope. So we should get positive outputs there. So let's just test that. Let's just see that we're going to get those calculations to match the tangent lines. So we're just going to test any point. So I don't know, let someone pick a number between negative infinity and 2, and we'll test the left side of that. What do you want to test? Any x value between okay, 1. William says 1. Oh, Chanel and William agreed. Okay, they both said 1. 1 is definitely between negative infinity and 2. When you test it, be sure to plug it into the derivative rule because this sign chart is describing derivatives. So if I plug it into the original function, that's going to give me a point on the graph. That's not what we're describing here. If I plug it into the derivative, that's going to tell me the slope of the tangent line. That's what we're describing on this one. So make sure you plug it into the derivative rule. So f prime of x equals 2 minus 2x minus 4. Yes, this it. Well, we're leading up to the first derivative test, Alan. Yes, we will use the sign chart in a minute to do first derivative test. Reading the chart will give us the first derivative test. I just don't want to call this right now we're just constructing a sign chart. Reading it later will lead to that. I know it's semantics. That's semantics. Yeah, you're 99.9% right. Okay, so let's plug in, what did y'all say, 1? Plug in a 1? Okay, let's input a 1. Okay, 2 times 1 is 2. 2 minus 4 is negative 2. That's what we expected. That's a negative 2. That's a negative output. So everywhere in that region will be negative, just like our graph said. And if we test something between 2 and positive infinity, hopefully we get something positive out because those tangent lines were positive. I don't know, let's test, I don't know, I just test 3. Into your derivative rule. Someone in here is going to plug it into the original function. Don't let it be you. We're plugging into derivative rule. That would be 2 times 3 minus 4. That'd be 6 minus 4. Woo! Positive. I don't care that it's 2. I care that that's a positive output. That's all I care about. So all the outputs would be positive. All the tangent lines in this region would be pointing up. And this is old by, I mean, the only new part of this is sign charts. This idea of negative slopes being negative tangent lines and sloping tangent lines and positive outputs being upward sloping tangent lines, that's old. We're just connecting it to a sign chart now. And later, Alan, we'll see that there's a minimum value there. That's the part of that derivative test. But we're not going to talk about that now. We're just practicing sign charts today. So in next class, this partition number right here, we're going to rename this a critical value, because what it's going to tell us is that we have a minimum happening there. If your tangent lines are pointing down and then they hit 0 and then they point back up, see how in algebra you learned that that was called a local min? This point right here where it was going down, then flattened, and then went back up, that's a local min. That was bad notation there. I shouldn't use that. But that local minimum is a critical value. Later, we want to know what the minimum cost is. And that's going to happen at this critical value, this point where the derivative hit 0 and we were decreasing and then increasing. We're going to talk about increasing and decreasing and all that next class. We just don't have time. We're just doing the sign chart now, so next class we'll go fast through sign charts. So just heads up, next class I'll fly through sign charts and you're expected to understand how to create them. We're just going to read them. Okay, we have 2 minutes. We can do the next one. Here's this brand new idea. We have not taught, this is our first time talking about second derivatives. So I'm going to zoom in real quick. We are going to calculate a second derivative. All that means is the derivative of the derivative. So we need to find the derivative. So f double prime is going to equal the derivative of the first derivative. The second derivative is the derivative of the first derivative. Does anyone know what the derivative of 2x minus 4 is? Just 2, that's right. It's a linear function, right? This happens to be linear, mx plus b. The slope is 2. Or you could just do your power rule, like however you see that. You're going to get that the derivative there is 2. You can just do your power rule to confirm that. Okay, this one's kind of weird for a sign chart, because I'm supposed to take the second derivative and ask myself, where would that equal 0? But my second derivative, no matter what my input x is, it's always shooting out a constant 2. So that means it's always a positive output. That means that there's no partition numbers. I can't break this sign. It doesn't change from positive, negative. It always, no matter what I plug in, if you just pick something, if you test a point, I don't know, let's pretend this was 0. So if, I don't know, if I test x equals -1 and I put it into the second derivative rule, it's going to shoot out a 2. If I shouldn't put 0 on there, but if we tested, if we test 0 and I put that into the second derivative rule, it's going to shoot out a 2. So see how it's always positive? What we're going to see next class is that this tells us the shape of the graph. Second derivative is going to tell us the shape of the graph. And in this case, the shape is going to be what we call concave up. What shape is our graph here? Look at your original graph. What shape is that? It's U-shaped. And it's pointing up. That's concave up. This is concave up. Everywhere. It's always a U pointing up. That's what the second derivative is going to tell us. It's going to tell us the shape of that graph. Okay, I know class time is over. I know y'all have another class to go to, some of you. So you do not need to even touch this homework, but you do need to rewatch this video over and over until you can be confident constructing a sign chart, because next class we're going to hit the ground running with sign charts, okay? So y'all are good to go. I can hang around for a few minutes if you have questions, but next class we'll finish these notes and I'm going to fly through sign charts. I'm not going to talk about how to construct them in super detail, okay? Okay, bye y'all. Bye Alex from McDowell. And Andreas, bye. Have an amazing day.
Hello?
Oh, yes, go ahead.
No, I was gonna say, I looked at my test and I do understand. I'm gonna tell you where I found that.
Okay.
When you teach it, I understand it. When I go and do my math lab, it takes me through all these different steps. And so at test time, I was trying to mix them all.
I totally feel you on that because when I took algebra for the first time, my homework grades were awesome and I felt so confident going into my first test. And then it was like, I don't know about you, but for me, it was like I blanked out because I realized I hadn't like weaned myself off the notes. Like I would go and I'd be doing my homework and I'd like peek at the help or, I didn't have my math lab, I had notes, but I'd peek at my notes and be like, oh, yeah. And it was just enough to spark me. And then I knew what to do, but then on the test, I didn't have that. And I like got lost. Did that happen to you or?
Well, no, I mixed them up. Like
Oh,
the D over DX thing, it asks you like if help, it asks you that. So you go through and you study that way to get it right on Math Lab.
I
But when
see.
you teach it, it's this way and I understand it and it don't connect up.
Okay. I do simplify things a little bit from my math lab. My math lab,
Right,
yeah, it
right.
teaches it like ultra traditional textbook STEM style, and this is a non-STEM class, so I kind of simplify the language. So what you could do, Chanel, when you're working my math lab, if you're using a help tool and it's explaining it a totally different way,
And
just
I
click.
don't understand it right. And it messes me up because I
Yeah.
be halfway through there and it's probably like one thing that I need to remember. But when I
Mm,
go there, it's telling me all this stuff in a whole different way. And I can't pinpoint the piece that I'm missing.
mhm. Can you, in that case, click ask the instructor when that happens, even if it happens a
Okay.
million times, and send me, say, hey, I'm confused on whatever part. I can make a video using the notation we used in class
Hmm.
and then explain it like the non-technical way. And then I can also explain it the technical way so you can see it both ways so the help tools will align. Like what we're doing, this notes we just did will really align with how my math lab does it. I'm doing it in a very traditional way right now.
Okay.
So, but the previous sections, I kind of like with all that derivative notation, I made it nicer.
And it was
So,
nicer. It was nicer until I got in there doing the
oh
homework. And so
no.
then I learned how to do it that way. And then it started mixing. It was mixing up because I was so used to doing, okay, just the Y at the derivative on. But then when I started doing the D and the D of
Mhm.
X, I understood it that way. But to match them up to find what I was looking for, it
Mhm.
was harder because I knew it two different ways. And
Yeah.
I, I still couldn't find what I was looking for because one way was telling me one your way,
Mhm.
I couldn't find it, and my math lab was trying to tell me to find it in a whole
Yeah.
different way.
That's one of the double-edged swords of me showing a different, like an alternative way to think about a problem is that it doesn't line up with my math lab. And when I'm teaching face-to-face and I'm not using my math lab, it doesn't matter so much because
Right, right.
it's
And
this
I get
added
that.
technology. Yeah, like because people just do it my way. So yeah, so definitely utilize that ask the instructor tool some more or reach out to our instructional associate because she teaches this class and she'll know other ways of explaining it that aren't my math lab, if that makes sense.
Right, right. My math lab
Mhm.
trips me up a lot. I
Yeah.
get it here,
Mhm.
and then when I go there, even if it's like one little thing that I'm off, I try and look for it,
Mhm.
but it shows it so differently. I
Yeah.
have to really try and look through there and find the part that matches up with the easy way that I learned it.
No, I hear you. And just heads up, if you do learn my math labs way, you can do that on the test and I'll count it totally right. Don't feel like you have to do it my way. like I had students that have taken calculus before and they're like, I learned it a different way. I'm like, you can do that until the cows come home and I will count it right as long as the steps are right. So
So
like
just
I totally see what you're saying about studying. It made it harder to study.
right.
Yeah. I don't know. Are you able to come to my normal office hours? They're before class, the hour before class, or early in the morning.
I
I
can.
don't know. You can? Okay, yeah,
Uh-huh.
maybe just try, even if you're just say, hey, that hour from noon to 1, I'm going to work on homework. And that way you could just do it quietly in my office hours. And if you have a question, I'm right there to help, maybe.
Okay. Yeah, that'll work.
Yeah, because I'm normally there. It's been an exception since I did have to leave Austin for a couple days, but I'll be
Hmm.
back in Austin next week. So you can just hop into my office hours and ask me any questions because then it's that live help. You're not having to ask an email question and wait for me to reply and then read it and then, you know,
Yeah.
but
Or I
yeah,
don't have to ask my math lab and they tell me something totally different. I'm like, what
exactly.
is
No, I
this?
agree.
What is this?
And in a 16-week course, it doesn't impact students as much, but we're too fast paced in the summer to spin your wheels on
Right.
whatever.
And that's what happened. I was spinning my wheels and I got frustrated.
We're the only, oh, let me stop the recording real quick. Sorry, I didn't
That's
realize.